Hi students, good afternoon to all. I welcome you all in this fluid mechanics lecture. So in the last lecture, we have solved a problem based upon the we have solved this problem based upon the uh, energy thickness, momentum thickness, then displacement thickness, right? So let me know from your side what was the last problem we have solved. Problem number, it was 3. I think this problem we have solved in the last lecture. So the other problems are similar to this one. So here, instead of wasting our time in solving solving this problem here, we will consider the new problem here and a new topic. And then if time permits us after completion of the syllabus, then we will have the practice on various kinds of problems that you consider if you find it difficult. At that time, we will have the practice on that problems. Okay. So now let us here move toward the next point, that is drag and lift. Okay. From this diagram, you can understand what is the meaning of drag and what is the meaning of lift. If you see the diagram here, there is a aeroplane has been shown here. The force, this aeroplane, it is moving in the forward direction, and this is the thrust which is given by this plane, and drag is the force which is acting in opposite direction to the direction of the plane. Plane's direction it is toward the left, and this drag is acting toward the left toward the right. So what does it mean? It does it mean that this drag is acting in opposite direction, and it is trying to reduce the trying to create the resistance to the movement of this particular object. It may be plane, it may be any object. Okay, for example, if you consider the example of car, okay, the car is moving here in this forward direction, so the drag will resist this movement of the car, and this drag force, it is created or it is generated because of the fluid surrounding the that object. Okay, this drag force जो आहे हे कशामुळे तयार होतो त्या ठिकाणी, it is created because of the fluid. Now surrounding this particular plane, which fluid is there? It is air. Air is there. So any object, it may be in the liquid. Okay, पाणबुडी सबमरीन वगैरे जे असते जे पाण्याखाली असते त्याच्यावरती पण त्या ठिकाणी drag force, it will be affected. If the submarine is moving in this direction, then drag force, it will act in opposite direction. So that resistance is called as the drag force. And then this is the lift. Lift means the force which is acting in upward direction. Okay, so whenever any object is moving in forward direction, at that time it will experience some upward movement, the force which is acting in upward direction. Okay, self weight is acting in downward direction, so against it, the force which is trying to lift the object, so that force is called as the lift. These are the two forces we should know as per our civil engineering point of view. So let us read here the definition and the theory about this. When a body moves through a fluid, कुठल्याही एखाद्या फ्लुइड मधून ज्यावेळेस बॉडी मूव्ह होते, the surrounding fluid exerts pressure forces. So that surrounding fluid which is there to this particular object which is moving, so that surrounding fluid, it exerts the pressure force and viscous forces on an object. So दोन फोर्स त्या ठिकाणी ऍक्ट होतात, विस्कस फोर्स आणि प्रेशर फोर्स, हे दोन फोर्स त्या ठिकाणी ऍक्ट होतात. The components of the resultant force acting on the object immersed in the fluid are the drag force and the lift force. Okay, these are the two components of the resultant force. The resultant force या ठिकाणी ऍक्ट होत असेल तर त्याचे component आहेत. One is the in vertical direction. If you resolve this resultant force, then it will have the two components, one force in perpendicular vertical direction and other force in the on the x-axis. These are the two components of the forces, that is drag force and lift force. Drag force is the component in the x direction or x-axis, and lift is the component in y-axis, right? Drag force acts in opposite direction of the motion of the object. So just now I have told you that this drag force, it always acts in the opposite direction to the direction of the movement of the object. ज्या डायरेक्शन मध्ये ऑब्जेक्टची मुवमेंट होते त्याच्या अपोजिट डायरेक्शन मध्ये हा ड्रॅग फोर्स त्या ठिकाणी ऍक्ट होत असतो. इट इज ट्राइंग टू ड्रॅग द ऑब्जेक्ट इन बॅकवर्ड. ओके, द ड्रॅग फोर्स ऍक्ट इन अपोजिट डायरेक्शन of the motion. The lift force acts normal to the direction of flow. If the direction of flow is here, of this object, the direction of flow is here. So to this normal direction, to this will be this direction. As well as this is also normal direction, but here weight is acting in this direction and lift is acting in normal direction to this object. Okay. Both are influenced by the size and shape of the object. So these both components, lift and drag, these both forces are influenced, affected by the size of the object and shape of the object. How much bigger size this object is and what is its shape. So this drag force and lift force both are affected or influenced by the size of the object as well as the shape of the object. Okay, and the Reynolds number of the flow, whatever the Reynolds number there, also affect the direction, that magnitude of this drag and lift. In fluid dynamics, sometimes called as the fluid, this drag force is also called as the fluid resistance. Okay, another type of the fluid friction. So this drag is a force acting opposite to the relative motion of any object moving with respect to the surrounding fluid, right? Just now we have discussed about that. Then drag forces always decrease fluid velocity. Okay, what this drag force is doing, as but obviously it is creating the resistance to the movement of the object. एखादा ऑब्जेक्ट जो आहे तो या डायरेक्शन मध्ये चाललाय आणि त्याला जर इकडून असा रेजिस्टन्स भेटत असेल, okay, surrounding resistance, या ठिकाणी जो फ्लुइड आहे, it is pushing, dragging this object in this direction, so definitely its velocity is going to get decreased. So that thing is mentioned here. The drag force always decrease the fluid velocity relative to the solid object in the fluid's path. त्याची velocity काय करते, relative velocity या ठिकाणी डिक्रीज करण्याचा प्रयत्न करते. This can exist between two fluid layers or a fluid and a solid surface. So this drag, it can experience, just we have seen in the unit number 1, that one layer of the fluid is creating the resistance to the movement of the another layer, and we call it as viscosity. So this drag force, we can call it as a viscous effect also. Viscous, due to viscosity, it is trying to pull this layer in backward direction. If the direction of movement is here, layer's direction, so this lower layer, it is pulling this or dragging the above layer here. So this drag force, it can be between the two layers or between the fluid layer and the solid object. The solid object ला चिटकून जी लेयर असते, या दोन्ही मध्ये पण त्या ठिकाणी तो ड्रॅग फोर्स हा त्या ठिकाणी एक्झिस्ट करू शकतो. ठीक आहे. So attendance is very less today. What is the reason? Very less number of students have joined the lectures. Now here, let us see the formula with the help of which we can find out what is the drag force. The magnitude of the drag force, which is represented by letter FD. This FD is nothing but it is the drag force. This magnitude is found to be proportional. It is directly proportional to the square of the speed of the object. Object जो speed आहे, let us say v is the velocity or speed of this object which is moving there. and then this drag force FD will be directly proportional to the velocity square. Okay, we can write this relationship mathematically as FD is directly proportional to V square. That is, drag force is directly proportional to the V square. When taking into account other factors, this relationship becomes, so बाकीचे factors जर आपण या ठिकाणी include केले, then we will get the equation like this. This is the equation for the drag force. FD is equal to 12 C into rho into A into V square. Okay, this is the equation for finding the drag force, where C is the drag coefficient. This C is nothing but it is drag coefficient. A is nothing but area of the object facing the fluid. Suppose this is the object which is facing, which is moving in this direction, and drag force is acting in this direction. So this capital A is nothing but it will be the this area. Okay, cross section area of the object will be the you can say it is the capital A. Control या ठिकाणी हे डायग्राम आपण सेपरेट असे दाखवली तर लक्षात येईल तुमच्या. ठीक आहे. So that is capital A. Then rho is nothing but it is the density of the fluid in which that object is moving. The value of drag coefficient C is determined empirically by using a wind tunnel. So there is one apparatus or device which is called like the wind tunnel. Okay, wind tunnel is there. With the help of this wind tunnel, we can find out what is the drag coefficient C. Okay, and then if you put that value of C here, we will get the formula for finding the drag force. This was about the drag force. I think you might have noted, if you have not noted this formula, so let us start from here. Then we will go toward the lift force. So write down the title in your notebook: drag and lift. Drag and lift. Right on there. When body moves through a fluid, the surrounding fluid exerts pressure force and viscous force. This viscous force can also be called as frictional force because it is responsible for the friction. When body moves through a fluid, the surrounding fluid exert pressure force and viscous force on an object. The components of the resultant force acting on the object, the components of the resultant force acting on the object immersed in the fluid are drag force and lift force. Next, write down there. Title here, drag force. After the second sentence, write down the title, drag force, and write down the sentence. The drag force acts in opposite direction the drag force acts in opposite direction of the motion of object. Opposite direction of the motion of object. Okay. Next, write down there. In fluid dynamics, drag is a force. Drag is a force acting opposite to the relative motion of any object moving with respect to a surrounding fluid. Next, drag forces always decrease. Fluid velocity relative to the solid object in the fluid's path. Next, write down directly खालची equation here. Drag force is given by equation FD is equal to 12 into C into rho into A into V square. Where C is the drag coefficient, A is the area of object facing the fluid, and rho is the density of the fluid. Okay. This was about the drag. Next, write down the title, lift force. Here, you can write here regarding the lift force that the lift force acts normal to the flow direction. Lift force acts normal to the flow direction. So let us understand about the lift here. So just I have told you that this lift is always acting in normal direction to the direction of motion. So if the direction of motion is here, if object is like this and it's moving in this direction, then the lift will be in normal direction to the direction of flow. Lift is always accompanied by drag force, which is the component of the surface force parallel to the flow direction. So lift force is always accompanied by drag force. Drag force त्या ठिकाणी continuously असतो. ज्यावेळेस लिफ्ट फोर्स असतो त्यावेळेस ड्रॅग फोर्स पण त्याच्यावरती ऍक्ट होत असतो. Okay, which is the component of the surface force parallel to the flow direction. Lift is the component of this force, that is, lift is the component of this force that is perpendicular to the oncoming flow direction. Flow direction च्या perpendicular मध्ये तो फोर्स त्या ठिकाणी ऍक्ट होत असतो. While common meaning of the word lift assumes that lift opposes the weight, while the common meaning of the lift assumes that opposes the weight, lift can be in any direction with respect to gravity. Okay, कोणत्या डायरेक्शन मध्ये लिफ्ट हे असू शकतं? Since it is defined with respect to the direction of flow rather than direction of gravity. ठीक आहे, ग्रॅव्हिटीचा त्याच्यावरती इफेक्ट होत नाही. इट डिपेंड्स अप सोली ऑन दी डायरेक्शन ऑफ मोशन. डायरेक्शन ऑफ फ्लो जसे असेल त्याप्रमाणे त्याची डायरेक्शन बदलते. नेक्स्ट इज स्ट्रीमलाइन फ्लो. ओके, so before going ahead here, write on about this lift here. Write down there, lift is always accompanied by drag force. Lift is always accompanied by drag force, comma, which is the component of the surface force. Parallel to the flow direction. Lift is always accompanied. Lift is always accompanied by a drag force. Lift is always accompanied by drag force, which is the component of the surface force parallel to the flow direction. ज्यावेळेस लिफ्ट फोर्स असतो त्यावेळेस त्या ठिकाणी ड्रॅग फोर्स पण डेफिनेटली इट विल बी देयर. नेक्स्ट राइट ऑन द टाइटल स्ट्रीमलाइन फ्लो, स्ट्रीमलाइन बॉडी. Streamlined body. So what is the meaning of streamlined body? You might have seen the various types of fish. Then you might have seen the birds. Their body is a streamlined body. Okay. Also, the vehicles, जे रेसच्या कार वगैरे असतात त्याचा पण शेप हा स्ट्रीमलाइन बॉडी सारखा केलेला असतो. सो व्हॉट इज द रिझन बिहाइंड स्ट्रीमलाइन बॉडी? Before that, we should know the meaning of streamlined body. Here in the diagram, you can see the streamlined body is shown here. The shape of the body is like this. So this is called as the streamlined body. If the body is streamlined, it is going to get very less resistance or very less drag. Okay. असे जर आपण शेप केला बॉडीचा then it will experience a least drag. So that body is called as a streamlined body. Can anyone give the example of this streamlined body? Here in the diagram you can see, if you compare the animals living on the land with those in water, you can see how drag has influenced the evolution. Okay, so resistance त्या ठिकाणी त्यांना continuously it was they were gaining the resistance. Okay, हा जर shape fish आहे, it may having the shape like this, but due to the continuous drag force acting on it, याच्यामध्ये इव्हॉल्युशन असं झालं की त्याचा शेप हा अशा पद्धतीचा बनला. So this body is called as a streamlined body. Okay, the body is very streamlined. Similarly to the birds, या ठिकाणी liquid creates the drag force. Here in the birds, as they are moving in the air is considered as the creating the drag force. Okay, also the flock of the birds, they are moving in this manner. So these are the examples of the streamlined body. Okay, so let us understand here now in depth regarding the streamlined body. Streamlined body is defined as that body whose surface is aligned with the streamlines when body is placed in the flow. Okay, very simple definition it is. A streamlined body is defined as that body whose surface is aligned with the streamlines. If you see there's a flow in the diagram here, the streamline flow is shown here, and this body is aligned with the streamlines. Streamline. Thus, body offers less resistance in terms of pressure drag. त्या बॉडीमध्ये खूप कमी प्रमाणामध्ये प्रेशर ड्रॅग आपल्याला पाहायला भेटतो. Most of the drag experienced by the body is due to the viscous or frictional drag, which depends on the surface area exposed to the fluid. So, सगळ्यात जास्त जो ड्रॅग त्या ठिकाणी एक्सपिरियन्स केला जातो, it is experienced by the body. It is due to the viscous or frictional drag, viscous force किंवा frictional force या ठिकाणी create होतो, which depends on the surface area exposed to the fluid. In this case, the separation usually takes place at the trailing edge. So the separation by fluid, body will be separate from the fluid at this tail edge. Okay. If you compare the animals living on the land with those in water, you can see how drag has influenced the evolution. इव्हॉल्युशन मध्ये कशी मदत केली इव्हॉल्युशन मध्ये. सो आपल्या ठिकाणी पाहायला भेटेल fishes, dolphins and even massivals are streamlined in shape to reduce the drag force. ड्रॅग फोर्स कमी करण्यासाठी त्यांची बॉडी जी आहे ते त्यांनी स्वतःमध्ये असा बदल करून घेतला की कमीत कमी ड्रॅग त्यांना त्या ठिकाणी जाणवला पाहिजे. Birds are streamlined and migratory species that flies large distances often have particular features such as long neck. You see there, long neck, it is again streamlined flow. Flocks of the birds fly in the shape of the spear head as the flock forms a streamlined pattern. पक्ष्यांचा थावा पण आपण जर बघितला तर ते कसे flow त्या ठिकाणी, it is similar to the shape of the spear head. Okay, and this flock form a streamlined pattern. So this is the last slide from this particular unit. Bluff body. A body is said to be bluff body. Okay. whose surface area is not aligned with the stream lines. So two types of bodies here we have seen. One is called as the streamlined body. ज्याच्यामध्ये body is streamlined, जसं आपण मागच्या डायग्राममध्ये पाहिलं. But here what? The body is bluff body, okay, whose surface area is not aligned with the streamlines when placed in the flow. What is bluff body? A bluff body is defined as that body whose surface is not aligned with the streamlines when placed in the flow. Thus, body offers lesser resistance in the terms of frictional force. अशा बॉडीमध्ये फ्रिक्शनल रेजिस्टन्सचा जो फोर्स आहे तो खूप कमी असतो. या ठिकाणी होणार there is very large pressure drag due to eddy formation after the body, leading to the large wake region. Okay, so here you can write down streamline body आणि याच्यामध्ये काय फरक आहे लक्षात आला सगळ्यांच्या? Streamline body कशी असते? It is shape is streamlined. Shape of the object is streamlined like this. But in case of bluff body is not streamlined, it is like this. So here wake region may form in downstream side. ज्या ठिकाणी fluid जो आहे तो fluid it is separated from the body. And there in case of this bluff body it offers a lesser resistance in terms of frictional drag. त्याच्यामध्ये viscous force प्रमाण resistance खूप कमी असतो. But there is a very large pressure drag due to the eddy formation after the body leading to the large wake region. या ठिकाणी हा force wake region मध्ये large formation of eddies it is going to occur there. Thus, the pressure drag depends on the cross-sectional area of the body rather than surface area exposed. Okay, so the pressure drag जो आहे कशावरती डिपेंड करतो? It depends upon the cross-sectional area. एरिया जेवढा मोठा तेवढा प्रेशर ड्रॅग पण त्या ठिकाणी मोठा होतो instead of surface area exposed. Surface area पेक्षा sectional area, cross-sectional area is very important here in terms of bluff body. Okay, so this was about this unit. Okay, so we have completed this unit number 5 right now. Now, if you want to write down this regarding the bluff body, you can note it down. Streamline body बद्दल लिहिले का आपण डेफिनेशन वगैरे लिहिले नसेल तर त्या ठिकाणी लिहून घ्या. Streamline body टायटल लिहा. A streamline body is defined as that body. Streamline body is defined as that body whose surface is aligned with streamline. Here you can see the diagram. त्याचे streamline आहे ते कसे आहे? त्याची डायरेक्शन ही अशी आहे आणि हे ऑब्जेक्ट पण कसं आहे? त्याच डायरेक्शन मध्ये असतं. So we can say this object as a streamline body. A streamline body is defined as that body whose surface area is aligned with streamlines when body is placed in the flow. here, second line. Thus, the body offers less resistance in terms of pressure drag. याच्यामध्ये स्किन ड्रॅग भरपूर असू शकतो, जास्त असू शकतो, किंवा जर आपण फ्रिक्शनल रेजिस्टन्स म्हणतो, इट मे बी लार्जर but very less pressure drag. If it is writing is over, then we will stop here. Bluff body राहील आपलं पुढचं. Write on the title bluff body. Draw the diagram. Is it over? Everyone? Shall we solve the problem now? Not on this bluff body, this streamlined body or bluff body or lift and drag. Here we will solve this problem here, which is asked in examination regarding the boundary layer thickness. Okay, write on the problem. The velocity distribution in boundary layer you might have become lethargic after the lunch. Right on there, velocity distribution in the boundary layer is given by u by v, small u by capital U is equal to, in bracket, y upon del bracket raised to 1 by 2. Calculate displacement thickness, momentum thickness, energy thickness, shape factor. So this question was asked in 2011 for 8 marks. So first of all, write down the given things. We are going to find out the displacement thickness. What is the formula for the displacement thickness? Who will tell? Roll number 6, Vaishnavi Honmani. Vaishnavi Honmani. Roll number 6. Roll number 9. Roll number 3.
Yes, sir.
What is the equation of displacement thickness?
Del star is equal to integration of 0 to del into 1 minus small u upon capital U into dy.
Okay. Now we have to put the small u by capital U. Instead of this, we have to put this value. Okay. So what we'll get here? We will get this part. Right. It is raised to 1 by 2 lile, 1 by 7 lile. It should be 1 by 2. इथं 1 by 2 आहे. Velocity distribution. Yeah. So instead of this here, 2 should be there. Right. By mistake, it might have written there. सेवनच आहे 1 by 7. काय तर चुकलेलं आहे इथं, दोन्हीपैकी एक काहीतरी चुकलेलं आहे. इथं 2च घ्या तुम्ही आणि सोडवा. Take here 1 by 2 and solve this. Now let us check what comes. Is equal to काय इंटिग्रेशन किंवा आधी मल्टिप्लिकेशन करून घ्या आतमध्ये ब्रॅकेट मध्ये 0 to del here. ब्रॅकेट मध्ये dy मायनस y बाय डेल ब्रॅकेट रेस टू 1/2. ओके, इथं 1/2 घ्या आणि सोडा बघू काय ते इंटू dy. ब्रॅकेट कम्प्लीट हिअर. Integration of dy, it will be y minus here this 1 upon del raised to 1/2, we will take it outside, and integration of this y raised to 1/2 as integration kind plus 1 divided by plus 1. We get here 3/2, right? Here again kind 3/2 divided by 3/2 or 2/3, it will become 2/3. Upper limit del, lower limit 0, put that values here. We will get here del minus 2/3 y raised to 3/2. Y means here del now. Del raised to 3/2 upon del raised to 1/2. So this power we can cancel it here. We will get here del minus 2/3 into del raised to 3. Okay. What will be the answer here now? जर आपण या ठिकाणी 7 घेतलं तर काय उत्तर येते बघा एकदा. 7 घेतलं तर काय येतं 1/7. 1/7 चं इंटिग्रेशन काय येईल y raised to 1/7 चं प्लस 1 आधी डिवाइड बाय 1 16 7 7 आणि हे 8/7. या ठिकाणी del raised to 8/7 separately I will write here y minus y raised to 8/7 7/8 del raised to 1/2. Right? 0 to del. Here del minus 7/8. Here del raised to 8/7. The del by 7. 1/7 will del raised to. The del raised to 1/7. This will get cancelled with this. We get here del minus 7/8 del raised to 8. Del star is equal to del by 8. Something mistake is there in the problem here. This will cancel with this one. Del to the power 8 will be there. This answer is not appropriate answer, correct answer. There might be mistake here. Momentum thickness, let us say about it. 1/7, 1/7 here. Integration. Here y is to 8/7. Hello. Yes. इथं y raised to 8/7 तर y raised to 9/7 येईल. ओके, आणि हे डिवाइड बाय 9/7 मग हे 7 वरती जाईल आणि हे 9 खाली राहील. तसं या ठिकाणी 8/7 हे 8 खाली आहे ना, डिवाइड बाय करतो आपण पॉवर 8/7 तर खाली यायला पाहिजे, ते 7 वरती जाईल 7/8 होईल या ठिकाणी. मग हे आपण डेल आणि 0ची व्हॅल्यू टाकल्यानंतर आपल्याला हे असं भेटतं 7/8 डेल रेस टू 8/7 डेल रेस टू 1/7 हे कट होऊन जाईल या ठिकाणी. ठीक आहे, पॉवर आणि ते काही पॉवर डेल रेस टू 8 येईल. हो, एक मिनिट हा, हे असं कट नाही होणार डायरेक्टली. आपण काय करूया, पॉवर वरती घेऊन बघूया काय होतं ते. समथिंग इज आय एम डुईंग समथिंग रॉंग. डेल रेस टू हे बेस सेम आहे, इथं पॉवर किती आहे 8/7 आहे, मायनस 1/7 इथं आलं. मग हे काही ह्याची पॉवर 7/7 होईल आणि ह्याची पॉवर फक्त इथं काय राहील, डेल राहील. ठीक आहे, कंट्रोल या ठिकाणी फक्त डेल राहील आणि या ठिकाणी पण तसंच होईल. ह्याची पॉवर वरती गेल्यावर काय होईल, -2/7. ठीक आहे, हे 9/7 मायनस 2/7 काय राहील या ठिकाणी 7/7 येईल. राईट, मग हे 7 कट होईल, या ठिकाणी भेटेल 1. या दोन्हीची पॉवर काय येईल 1 येईल, त्यामुळे 7/8 डेल. ठीक आहे, 7/9 डेल. हा डेल कॉमन काढला या ठिकाणी आणि याचा बेस सेम करून घेतला 9/8 त्याला 9ने मल्टिप्लाय केलं आणि ह्याला 8ने मल्टिप्लाय केलं तर काय या ठिकाणी 9×7 = 63 मायनस या ठिकाणी 8×7 = 56. ठीक आहे, मग या ठिकाणी किती आलं 4 आणि 3 7. सो अशा प्रकारे आपल्याला इथं थिटा भेटला. मागच्या याच्यामध्ये पण तसंच असेल. विल गो बॅक हिअर. येस, डेल रेस टू 8/7 मायनस 1/7 पॉवर वरती घेतली आपण. तर हे बघा, त्याचा बेस सेम आहे, डायरेक्टली आपण सबट्रॅक्ट करू शकतो. सो डेल रेस टू 7/7 7 विल गेट कॅन्सल आणि विल गेट हिअर डेल. ओके, तर फक्त आपल्याला डेल आलं. सो ह्या सिग्मा मायनस 7/8 डेल, दिस इज डेल मायनस 7/8 डेल. याचा बेस सेम करून घ्या. तर मग आपल्याला या ठिकाणी काय 8 मल्टिप्लाय करावं लागेल, 8 डेल मायनस 7 डेल डिवाइडेड बाय 8. सो विल गेट हिअर 8 - 7 इट विल बिकम 1, दॅट इज डेल बाय 8. तर हे अशा पद्धतीने हे आपलं उत्तर आलेलं आहे. दिस वॉज द पार्ट 1 मोमेंट ऑफ थिकनेस एक झाला. शेप फॅक्टर h is equal to del star upon theta, right? So this value टाकून द्या, you will get here the value of shape factor. Del upon 8 7 del upon 72, so del will get cancel. You want to simplify me, 8 by del, okay, into a खाली 1/7 72 वरती जाईल divided by del. So del will get cancelled here. 9/8 इथं 9 आलं. So we'll get here 9/7. 9/7 is nothing but 1.286. Shape factor. Energy thickness. Energy thickness is nothing but del double star. This is the formula for energy thickness. Del double star is equal to integration between the limit 0 to del small u upon capital U into 1 minus u square upon u square into dy. So now instead of putting this small u upon capital U, we will put here y upon del. So we have put here y upon del raised to 1/7 into, in bracket, 1 minus this y upon del raised to 2/3, 2/7. Okay. Then multiplying this value inside this bracket, so we'll get 1 into this del, we will get this value, and again multiplying this with this, we will get here, as the base is same, y upon del याची पॉवर आहे 1/7, याची पॉवर आहे bracket complete 2/7, so we'll get here 3/7. Okay, so y upon del raised to 3/7 we will get here. त्याच्यानंतर इंटिग्रेशन करायचं. इंटिग्रेशन मध्ये काय येईल? हे 1/del⁻⁻⁷ ॲज इट इज. इथे येईल, इथे काय येईल? y⁻⁷ + 1 divided by 1/7 + 1. Okay, do that minus as integration. So 1 हे अगोदर या ठिकाणी मी लिहून घेतो. 1/del⁻⁷ into y⁻² काय येईल? 3/2 divided by 3/2 हिअर असेल ते 2 वरती जाईल. So 2/3 असं लिहिता येईल आपल्याला. ठीक आहे, तसंच याचं पण सिम्प्लिफिकेशन करून घ्या. You can see here 1/7 आहे, 1/2 घेतले मी. So this upper integration we will get here y⁻8/7 del⁻1/7. Here y⁻10/7 del⁻3/7. Okay. After putting this upper and lower limits, we will get here del in the numerator, del in the denominator. Do the division of these powers, and you will get del star is equal to 7/40 into del. Okay. In this way, we have to solve this problem based upon this displacement thickness, energy thickness, and momentum thickness. So time is about to finish. Let me take your attendance. So we have completed this unit number 5. From the next lecture, we will start with the unit number 6. Okay, that is dimensional analysis. And last 2 units, unit number 7 and 8, that will be taught you by other staff faculty member. Okay, Jagdal sir, he will teach you the last 2 units, that is impact of Z and centrifugal pump. And he will have the lecture on your class on Wednesday morning session. In the week, 2 hours will be given to him to complete that 2 units. Are you getting my point? What I am saying? शेवटच्या 2 युनिट साठी तुम्हाला 2 युनिट शिकवायला दुसरे फॅकल्टी येतील. As we have to complete the syllabus, so now only 1 month is remain, and within that 1 month we have to complete 4 units. अजून आपले 4 युनिट राहिलेले आहेत. तर त्यासाठी राहिलेले 2 युनिट हे मी घेणार आहेत आणि दुसरे 2 युनिटसाठी आपण दुसरी फॅकल्टीला सांगितलेलं आहे. सो ही विल टेक सायमल्टेनियसली आमच्या दोघांचे पण लेक्चर असतील. बुधवारी सकाळच्या सेशनमध्ये 2 तास त्यांना दिलेले आहेत आणि बाकीचे लेक्चर्स मी घेईन. ठीक आहे, आणि ते त्या 2 तासामध्ये he will teach you the unit number 7 and 8. Okay, unit number 5, unit number 6 and unit number 4 that I will cover. Okay, in this way we will finish your syllabus in this month. So that is from my side. So let us stop here. I have taken your attendance. Now we will close the session. If anyone having any query, doubt, you can ask me. Otherwise, I will close this session. तुमचं आता या ठिकाणी I think your lecture will start at the 3 o'clock. Okay, so you will have the break now. So shall we stop here now? Thank you for all of you for your precious listening.